Hi, welcome back. So now we're going to be talking about the next type of functions, which is your exponential and log functions, right? So the four things, again, applies here. Restrictions, intercepts, stationary points, asymptotes. So there are restrictions this time, and we need to check what the restrictions are before we actually sketch it. But don't worry, you will be able to use your GC to do this pretty simply. Intercepts, there might be. Note that there are no stationary points for this, and there are asymptotes for this. Okay, so expo and log functions, they all have this. So I'm going to be using this example over here to showcase to you how to sketch expo and log functions. But feel free to pause this video to try it out for yourself first, based off what you know from the previous video, because the technique is about the same, but I'm going to show you exactly how to sketch it now. Okay, so I'm going to guide you through these two portions over here. So the first one, we can see that this is an expo function and this is a log function. And at the core of it, every time you sketch, just use your GC. So y equals to 2e minus x plus 3. So first thing I'm going to do is that I'm going to open up my x and y axis over here. And then I'm going to go back to my GC and actually sketch it. Alright, so I'm just going to come back here. I'm going to clear the previous example. Now I have 2, and then here I have e to the power of a negative. Note that for negative, right, you have to key this one and not this, because this is minus and then this is negative. So it's negative. Okay, negative x, then bring down plus 3. Okay, I'm just going to graph it. And then you see that it looks like that, right? And if I were to zoom in, you see it goes down and then it goes and it flatlines. So there is very clearly a horizontal asymptote over here. So if I were to come back to my graph here and sketch, I'll sketch it this way, right? And then over here, I'll draw a dotted line to show my horizontal asymptote. So my horizontal asymptote is very clearly y equals to 3, right? Because of this plus 3 over here. But then if you are not too sure, you can just come back to your graph here and you count, right? This is 0, 1, 2, 3, right? And at 3 over here, you see that, okay, let's say I just draw a line of y equals to 3 over here. You see that this is the line that it never touches. I know it looks like it touches here, but that's because of the restrictions of the graph, of the graphing calculator. But we know that as mathematicians, it never touches, right? If I zoom in even more, you'll see that they actually don't touch, right? If I, let's say I zoom in here, maybe I zoom in a bit more here. Okay, here, let's say I zoom in here, right? They actually don't touch. Very, very close, but they don't touch. So that's it, right? And then over here, I just need to find out what's the intercept. So I can just zoom back out again. And then here, I just trace to find out what's the intercept, right? So second, shift value 0, 5. So I just need to come back here. I just need to label this as 0, 5. And that's the answer already, right? This is y equals to 2e minus x plus 3. And that's the final answer to this portion here. So there's a asymptote, and for asymptotes, we draw the dotted line because it's not a line that the question asks us to sketch, right? They never ask us to sketch the line for the asymptote. So I cannot leave it as a bold line. I'll leave it as a dotted line to indicate that I know there's a asymptote there, but it's not part of the main graph. So only the main graph is, the line is bolded all the way. Okay, so just take note of that. Okay, for B, same logic. Y equals to ln x minus 1 squared. So I come back to the GC and I clear this and I clear this, then I come back here, right? And then I just go to ln x minus 1 close square, graph it, right? We can see that here is the graph, and it looks very weird because these graphs are like, it seems like it ends, right? But it doesn't end, right? It's just the asymptote, because we know that this one cannot be 0. So x minus 1 cannot be 0, and therefore x cannot be 1, right? And we can see that when x is 1, it becomes undefined, right? So we know that there's just a vertical asymptote there. So if I sketch this out, yx here, we know that over here, x equals to 1 is a vertical asymptote, right? And if we were to, let's say, zoom in here, you see that there's an intercept over here, right? So overall, the graph, when I sketch it, it will look like that. Can we use a different color? Very near, touches once, and then it goes back up like that, right? And then maybe I adjust it. So it very close, it touches, and then it goes like that, right? And then here, this value would be, I mean, I already got it there, right? This is 1.97, and that's the final answer over there for this portion over here. So yeah, you can see that this is what we have over here, and that would be about it for this graph over here. Yeah, so at the end of the day, just use your GC. It's very, very easy. And with that said, if you have any other questions, feel free to leave it in the comments below. Otherwise, I'll see you in the next video.